Good morning, everyone. Thank you for joining us for part 4 of our mini-series. We're going to give it just another minute to let everyone log on. If you guys have any questions, you can go to your control panel and under the questions tab, you can type that in. If you need any
It's 10 o'clock.
Good morning, everyone. Thank you for joining us. This is the Emerging Market Opportunities for Air-to-Water Heat Pumps. This is part 4 of the mini-series. Go ahead and go to the next slide. Today, my name is Carly. I'm a marketing and event strategist, and we'll be joining, and then along with Tim Wright, VP of Sales at Enertech, Jeff Hammond, Vice President of Technical Services at Enertech, Jim Cusack, Special Projects Manager at Enertech, and John Siegenthaler of Appropriate Designs, who will actually be presenting today. Like the previous webinars, we will be covering a lot. So to get the most out of this, we encourage you guys to take as many notes as you can. If you don't get everything that you can get, we will be sending out a recording with the webinar presentation and the recorded webinar out for everyone. If you guys have any questions, feel free to put them in the questions tab on your control panel, and we will answer the questions at the end of the presentation. If time allows, if your question does not get answered, don't worry, we will reach out to you directly and get those answered. I will pass it over to Tim.
Hey, good morning, everybody. Thanks for joining us on this webinar number 4. So this is the last of 4 right now, highlighting example systems using Enertech air-to-water heat pumps, better known as our Advantage product. So just a huge thank you for taking time to spend with John and Jeff Hammond, myself, Jimmy Cusack, and Carly. This has been a wonderful opportunity for John to just walk back through good design principles, and we're excited today to kind of wrap this up. So again, Carly had mentioned that all of these are recorded, and please make sure that you take time to look at the Enertech YouTube channel, Enertech University, just as a reminder or a refresher for your team later on. So John, thanks again for bringing this series to us. It's been a tremendous effort on your part. And Jeff, it'll be fun to help wrap this up at the end of today. But John, take it away. Thank you.
Okay, well, thanks, Tim and Jeff and Curly. Yep, as Tim was saying, we're at 4 out of 4 now. So what are we going to be doing? Well, we're going to be rolling some of the topics that we've talked about in the previous 3 into complete systems. And we'll start with relatively simple heating only systems. And we're going to build as we go. We're going to add domestic water, which is pretty common in most hydronic heating systems in residential construction. Typically, the hydronic system is set up for domestic hot water, and certainly that provision is available with the Advantage unit. We're also going to look at dual fuel. That's where we bring another boiler, another heat source, typically a boiler, into the system, and it can serve as a backup. It could also provide heat when you have on-peak electric rates. Some of you may have what are called time of use electric rates, where during the off-peak period, it would be beneficial to provide the heat through the heat pump, lowering the cost of the energy. And during on-peak periods, the boiler could provide that heat. So there is a model of the Advantage unit that is set up with controls to automatically operate that boiler when necessary. And then we're gonna branch out into multi-zone systems, where we have several zones in heating and potentially even several zones in cooling. And then at the end, Jeff is going to take you through some of the design assistance resources that Enertech offers. He's also going to take a look at the GeoAnalyst software, which does have capability at this point to simulate the performance of the Advantage heat pump in different climates with different buildings, and assuming those buildings have different types of heating distribution systems. And that really gives you a good feel for what the seasonal performance of those units are going to be. And then we'll wrap up at the end with some Q&A. So let's start off with this. This is what I'd call the typical system. This is really the type of system that the Enertech unit was originally conceived around, where we have the outdoor unit, we have a piping set that comes into the indoor unit. And again, this is not refrigerant piping. All the refrigerant is factory charged and sealed in the outdoor unit. So we have piping with an antifreeze solution that comes into the indoor unit, and the controls and the hardware necessary to route that energy to several different loads is contained within this indoor unit. So on space heating, what we're doing over here, we're showing a component called a hydraulic separator. Those of you that have been involved with hydronic systems for a while are probably familiar with this at this point. 10 years ago, this was a relatively unknown device in North American hydronics. Well, what it does is it basically separates the pressure dynamics that this circulator, we'll call that the distribution circulator, creates, versus the pressure dynamics of the circulator that's inside that indoor unit of the heat pump. That's important because actually that circulator that's in the indoor unit of the heat pump is a variable speed circulator, and it's being controlled based on the logic of the heat pump. So we don't want another circulator in the system to interfere with the speed that that circulator wants to run at, and vice versa. This circulator is common today. In fact, we talked about it last week. Pretty much all the circulator manufacturers now offer what is called a variable speed pressure regulated circulator. This is a circulator that will automatically adjust its speed as it senses opening and closing of, in this case, zone valves. And I've just set up a very typical system where we may have, in this case, 3 zones of space heating. I'm showing low temperature heat emitters like radiant panels. And again, it could be floor heating, it could be radiant walls, radiant ceilings, but it could also be other heat emitters. It could be fan coils, it could be panel radiators, and it could also be a combination of those emitters. So you have a lot of versatility in terms of how you select a palette of heat emitters depending on what those project requirements are. And I'm also showing a fan coil here. Now this fan coil could be used in heating mode, but I'm showing it as a cooling mode. So when the unit is generating chilled water in the summer, this zone would open, the circulator would be on, and we would be pumping chilled water up through that fan coil. So we have heating and cooling taking place on in this case, the left side of this hydraulic separator. And in addition to keeping the peace between these 2 circulators, this is also providing your high efficiency air separation in the system. So we get the micro bubbles out of that fluid. And in the bottom here, in a lower portion, it's also acting as a dirt separator. So it's really 3 functions. Many of the newer ones also have a strong magnet at the bottom. I'd recommend that anytime you're using high efficiency circulators. And the reason for that, the high efficiency circulators have very strong permanent magnets in the rotor, and you don't want any iron oxide particles flowing through the system. The circulator manufacturers certainly take steps to minimize the impact of that, but the cleaner that fluid is, the better. Now, again, the indoor unit is set up so that it can automatically go to a TurboMax indirect water heater. And we talked about the importance over the last several webinars. We talked about the importance of low water temperatures. And when it goes to domestic water heating, obviously we need water temperatures, I would say as a minimum in the range of 110 to maybe 120 degrees Fahrenheit. So the unit is going to operate probably at a slightly higher temperature during the domestic water load. And that's why we want to have a lot of surface area inside that tank. And I do want to stress that TurboMax tank was not an arbitrary decision. That was a product that was well matched to the performance of the heat pump. The idea being to minimize the temperature difference between the water that the heat pump is heating, which would be in the shell of this tank, and the temperature of the domestic water. The more heat exchange area we have in that tank, the lower we can operate the heat pump and still get adequate domestic hot water delivery temperature. And then the final component over here, this is an anti-scald mixing valve. I would certainly recommend you do that on any water heater, regardless of what the heat source is. It would prevent water at temperatures over 120 degrees is typical from going to the fixtures, okay? So that's the overall system there, and it brings together many state-of-the-art components like high-efficiency circulators and the hydraulic separator and the high-performance TurboMax indirect water heater, okay? It also has the electric version of the heat pump has built-in 9 kilowatts of electric resistance heat. So it has its own built-in auxiliary heating system. I suppose this latest blast of cold air down through the Midwest and down into Texas can convince people it's good to have an auxiliary heating element anytime you have a heat pump, not only for abnormally cold temperatures, but as a backup. If there is any service that's done on the refrigeration system, you do have backup heating. And 9 kW converts to roughly 30,000 BTUs per hour. So it's a pretty significant amount of auxiliary heat capability. So as they say, that's a typical system, kind of what the concept of this heat pump was designed around. Now, there's going to be some special applications, one of which is a heating only application. And some examples of that would be, it could be a residential application, but more typically, it might be something like a firehouse, ambulance garage, maybe a commercial garage type structure, okay? And those are ideal for floor heating. Low temperature floor heating is going to allow that heat pump to perform well. The unit that I'm showing here would be the electric unit, okay? So again, it has that built-in auxiliary heating. And that's important because any air source heat pump does have to have a source of heat when it goes into defrost. When you have high mass slab heating, you have a lot of thermal mass out in that slab, actually an enormous amount of thermal mass. And the heat pump can draw from that mass the energy that it needs to melt the frost on the outdoor unit. It can also operate the 9 kW elements if necessary to get that heat. And that's, in the case of a high thermal mass slab, you're not going to feel that. That's one of the advantages of air-to-water heat pumps versus ductless mini splits. With a ductless mini split, you don't have that mass. So when it goes into a defrost, that heat has to come directly from the conditioned space. So you're going to feel cool air coming out of those wall cassettes under a defrost mode of operation, okay? A few notes that I put in there. One is check the size of the expansion tank. Now, there is an expansion tank built into the lower left of this indoor compartment. But if you have a very large distribution system with a lot of water volume in it, maybe 100, 200 gallons of water out there, the expansion tank that's built in there may not be large enough, in which case you can add another tank to the system. So I showed it there, and the only way you're going to know that really is to do a calculation based on the volume of water that's in the system, what the expected temperature change would be from a no heat condition up to a maximum temperature condition. And there's many ways to do that. There's software, there's charts. If you calculate you need a 5-gallon expansion tank, there is tapping down here that you can use to add that extra volume expansion tank. Again, we're back to that standard setup right here, space heating plus domestic water. As I mentioned, most residential applications, and really this unit was designed primarily around that concept, are going to have the need for domestic water in sufficient quantities that it makes sense to heat that water with the, and certainly keep in mind, domestic water heating is an annual load. It's present 12 months out of the year. Whereas, obviously space heating is in the winter. So on an annual basis, the COP that you're going to have of that unit taking advantage of those warmer temperatures in the summer is definitely going to be higher than what that seasonal COP would be if it was just doing space heating in the winter. Just a matter of how warm those outdoor temperatures are going to be. So a COP of perhaps 2.5 to 3 is certainly going to reduce the water heating costs significantly over an electric resistance heater. So it is worth the cost of using a high performance indirect and taking advantage of that over many years of service, greatly reduce domestic hot water cost. Okay. Now, another option with this system is a configuration on the indoor unit control capability to operate an auxiliary heat source. And it's referred to as a dual fuel system where I'm showing here a ModCon boiler that could operate on natural gas if the house happens to have natural gas service, and it might or it might not. It could operate on propane. Would also be possible to tie in a conventional boiler, for example, operating on fuel oil. One word of caution when you do that, if you're tying in any type of a conventional boiler, and by that term conventional, I mean a boiler that was not designed to operate with sustained flue gas condensation. And you're going to a low temperature distribution system, radiant panels or low temperature heat emitters of any sort, it's really important to protect that conventional boiler against flue gas condensation. We have seen situations where conventional boilers have been destroyed when a hydronic system was converted from its original high temperature heat emitters into a low temperature system. And when that return water temperature to the conventional boiler drops below about 130 degrees, you will start to form flue gas condensation. And there are mixing valves that can easily be installed and protect that boiler. I just want to bring it up as a check mark. If you're retrofitting a system that does have a boiler that was not intended to operate with flue gas condensation, make sure you do that boiler protection. Now, I mentioned earlier, the controls that are in the indoor unit of the Enertech heat pump can automatically operate that auxiliary boiler. And the piping here, basically what I did is I took the previous piping diagram and I just added that boiler in parallel with the indoor unit of the heat pump. So again, we have a circulator built into the indoor unit that's going to provide the flow up through, and you'll see there is a check valve there, over to the hydraulic separator and then back into the indoor unit. And of course, this circulator then takes it from there and sends that fluid off to whatever zones are open. Now, if the boiler is operating, I'm showing a circulator with a built-in check valve. It is important that you have a check valve in any situation where you have parallel pumps. You don't want one pump creating flow in reverse through a circuit that has a circulator, but the circulator is off. So if this circulator is on, that flow comes out and it cannot go backwards because of this check valve right here. And vice versa. If the heat pump is providing flow through here, we cannot induce a reverse flow because in this case, we have a check valve built into the circulator. It doesn't really matter whether it's an integral check valve in a circulator or whether it's a separate check valve. I tend to like spring-loaded check valves over what are called swing check valves. The swing check valves, they're okay, but they have to be mounted in a horizontal position. And with any check valve, a good detail is to provide at least 10 pipe diameters of straight pipe upstream of that check valve. And the idea is that you don't want highly turbulent flow going into the check valve. That could cause the mechanism in the check valve to rattle a little bit. So again, it's just a little hydronics 101 detail. Put some straight pipe out in front of those check valves when you install them. So that's the dual fuel application. Again, that would be a specific model of the Advantage indoor unit. So we're going to do a poll question. Carly's going to run this. We've been talking about adding or the presence of domestic hot water in hydronic systems. So we're going to ask you, how many of the hydronic heating systems that you install in residential buildings, think homes now, also provide domestic hot water? And those are the choices. So I'm going to let the poll run, and then we'll summarize that. And the numbers are coming in. Looks like quite a spread here. Okay. Right now, there we go. We close the poll. And I'll read the results off to you. In the less than 25% category, 26% of you said that in the hydronic heating systems you install, less than 25% of those systems are including domestic water heating. In the 26 to 50%, the response was 18% of you said your systems are including domestic water in 26 to 50%. Let's see, 22% of you indicated that domestic water was included in roughly half to 3/4 of the systems that you install. And the winner is 34% in over 75% of the systems. So as expected, domestic water heating has been a strong, what we call ancillary load to hydronic space heating. And certainly with the Advantage heat pump, you've got that capability. So, all right, now I'm gonna change things up here a little bit. Last week, and I believe previous to that, we also talked about panel radiators. And these have been around for decades. They're used by the millions in Europe. And in all honesty, they're one of my favorite heat emitters. They're very easy to install. Basically, that panel radiator you see over here in the upper left, that just hangs from brackets on the wall. That panel probably weighs in around 100 pounds. Certainly, it's a lot lighter than an equivalent cast iron radiator. And you'll see the two 1/2-inch tubes coming up here through the floor. In this case, it's 1/2-inch PEX aluminum PEX, but that could easily be PEX tubing. It could be copper. There's adapters for all different types of piping connected to the radiator. There actually is an isolation valve set up at the bottom here. But the nice thing about a panel radiator is that you get both radiant heat output from the face of the panel, as well as some convective output. So you definitely get what I would say is a higher level of comfort based on that radiant output. And interestingly, the lower the water temperature that you operate these radiators at, the higher the percentage of the total output goes as radiant heat versus convective heat. So low temperature operation of these panel radiators is definitely favorable, definitely possible. And the other thing I want to point out, you'll see this knob here in this upper right corner. Here's kind of a zoomed in picture of it. This is the thermostat for the room. There's no wires, there's no batteries. And basically you just turn that knob. You see right now it's set for the number 3. And there are no temperatures indicated on these knobs. And that's kind of a smart move from several standpoints, one of which is you can sell it to people that use Fahrenheit as well as people that use Celsius. There's numbers from 1 to 5, and a typical indoor comfort setting, approximately 68 to 70 degrees Fahrenheit, would correspond to a number 3 here. So you see it's set at 3. Inside that knob, you actually have a little wax-filled device, or some of them use a gas-filled device that expands and contracts in response to room temperature. and that varies the flow rate through the panel. So the beauty of this is, if you look at the overall system here, I'm showing 6 panel radiators. They could be different sizes, different heights, widths, thicknesses to match the room heat load characteristic. They all connect back to a manifold using either 1/2-inch PEX or PEX aluminum PEX tubing. Here's a photograph that shows the manifold. And as such, they're all in parallel. So they're all going to get approximately the same supply temperature. And each one of those panels operates as a separate zone. So you could have situations where a room gets some solar gain, or maybe there's equipment that turns on, and that thermostatic valve will automatically adjust the flow rate in that panel so that the room doesn't overheat. And as far as the balance of the system, we've got our standard Advantage heat pump setup, except for one substitution. What I've done is I've removed the hydraulic separator and I've installed the GeoFlow buffer tank. This is a polypropylene pressure vessel with fiberglass as a reinforcing shell, very well insulated. And what it does is it adds thermal mass to the system. One of these panel radiators, if it was turned on, could have a very low demand for heat, maybe 1,000 or 1,500 BTUs per hour. Well, even though the Advantage heat pump is a modulating unit, it doesn't modulate that low. So it could maintain a temperature range in the buffer tank, and that temperature range could be based on a set point. For example, we could turn the heat pump on when the buffer tank temperature drops to 100 degrees, let it run until the tank gets up to, let's say, 110 degrees, okay? Or that could be based on outdoor reset control. As it gets warmer outside, the temperature we're maintaining in the buffer tank goes down, and that would favor higher COPs out of the heat pump. So essentially, think of the heat pump as, I use the term battery charger. We're maintaining our thermal battery. We have quite a bit of thermal mass there. And now each panel radiator simply draws water as necessary. This circulator could be turned on in the fall, and it could be energized 24/7 right through the heating season. And some of you might be thinking, isn't that going to use a lot of electricity if we leave it on? We've actually done some calculations on this, and we find those circulators can run on the order of like 4 or 5 pennies per day, with electric rates at maybe 10 cents a kilowatt hour. This is a very small amount of electricity. And essentially at that point, you've got a system, I'll describe it as cruise control. You've got cruise control on the circulator speed, and you also have cruise control on a room by room basis for temperature. So it's a simple, very repeatable concept where I'm showing 6 panels. There could be 3, there could be 4, there could be 8. You would just scale the manifold up, and it's a really nice tie-in with the heat pump. I will stress, as we talked about in previous webinars, make sure you size these panel radiators for low water temperatures. I would suggest an average water temperature at design load of about 110 degrees. And that's well within the operating range of the heat pump. It's going to allow the heat pump to operate with good heating capacity as well as good COPs. Now, it does result in larger radiators. If you're thinking that, you could heat a large master bedroom with a radiator 10 inches high and maybe 18 inches wide, you could do that with 200-degree water, but you cannot do that with a heat pump. So yes, the radiators are going to be larger when you go to lower water temperatures. And last week, if you missed last week, we talked about actually some of the calculations of how do you know what the output of a given size radiator is at that low water temperature. Fairly easy to figure that out. Okay. Now, we took that system and modified it again. What I did here is I added a single zone chill water fan coil. So this could be a horizontal or a vertical fan coil unit. GeoComfort has those units available. They have the drip pans in there for condensate. So we're using a single zone air handler with chilled water for cooling. And the way the piping is set up here, remember, there is a circulator inside this indoor unit, but that circulator isn't necessarily sized to drive flow at the proper rate through a chill water fan coil. We don't know how big that coil is. We don't know how much piping is between that fan coil and the heat pump. So rather than expect the circulator in the heat pump itself to provide all the flow, I'm using a separate circulator, and we're interfacing that with a pair of closely spaced tees. This is another form of hydraulic separation. What this does is it allows the circulator in the heat pump to provide flow in this loop right here, okay? Relatively low head, low pressure drop loop. And then this circulator picks up that chill water, sends it up through the coil, brings it back, drops it back into that loop. By keeping these tees close together, we're hydraulically separating the pressure dynamics of the circulator that's in the indoor unit from the circulator that we've sized specific for the chill water coil, okay? And those of you that are new to chill water cooling, it's imperative that you insulate and vapor seal any piping and piping components that are carrying chilled water. We talked about those details in one of the previous webinars. Make sure you get some insulation around the circulator volute, all the piping. The diverter valve that I've got here, see the insulation is around the valve body, but not around the actuator head. Same on a circulator. You don't wrap the motor can of the circulator with insulation. I would recommend you put a balancing valve in here that will allow you to set and measure the flow rate going through the chill water coil to get that balanced out. So over here, just an abbreviated version of what I showed previously. We've got the buffer tank, and we've got room by room zoning going on with panel radiators with thermostatic actuators on those radiators. So we're bringing a lot of state-of-the-art hydronics technology, and we're building a kind of a comprehensive system here for space heating, cooling, and domestic water heating. Let's take it one more step. This time I'm going to go zoning on the chilled water side. So rather than a single air handler, these could be multiple small air handlers. They could be ducted. We've done projects in the past on large residential projects where we've installed, it might be maybe a 2-ton air handler in a area of a house, and did some ducting around it. And then in, perhaps an area 100 feet away, there might be another air handler, again, some ducting around it. So instead of trying to centralize, what might ultimately be 8 or 9 tons of cooling, you're using hydronics to go out to what I call satellite air handlers. And then you're clustering short amounts of ducting in those spaces around those air handlers. Now, the other option would be fan coil units. You can get high wall fan coil units. They look virtually identical to a ductless mini split high wall cassette. They're set up with chill water coils and drip pans. You can also get console fan coils, some of which mount to the surface of the wall down low, where the wall comes down to the floor, and some of which can be installed in recessed cavities. Critical thing, make sure any fan coils that you intend to use for chill water cooling are equipped with drip pans. And you'll see I've shown a drain coming out here with a trap. These are going to produce condensate, and that condensate has got to be routed either outside or into some type of a drainage system. Never use a fan coil that was just set up for space heating in a chill water application. So how are we creating flow? Well, we're using another variable speed pressure regulated circulator. We've got zone valves shown on the individual fan coils. In this case, I'm showing the zone valves implying that they're out near the fan coil. In some cases, these zone valves are actually built right into the fan coil units. The other way you could do it would be more of a home run arrangement, where you keep the zone valves as well as the balancing valves. You keep all that in the mechanical room, and then you go out with insulated piping to these console fan coils. Last week, I believe I mentioned you can buy pre-insulated PEX tubing. We've used 3/4 inch pre-insulated PEX tubing. I like it because you don't end up having to slide the insulation on it, glue it, so forth. You basically uncoil it, pull it through the building, and you've got a insulated and vapor tight piping system for chilled water. So we've started from very simple heating only applications. We've built up through domestic water, single zone cooling, and now we've got multi-zone heating, multi-zone cooling, as well as domestic hot water. Now, I'm just showing you, what we've talked about so far. I'm showing you just a sampling of some of the potential applications. The installation and operating manual for the Advantage heat pump does have schematics in it. And I would certainly encourage you to take a look at those schematics. Many of them are very similar to what I've shown you. And over time, it's likely that that will be expanded in terms of other applications. So with that, I'm going to hand controls over. Well, I'll hand the narration over to Jeff Hammond. And Jeff, just let me know and I'll advance the slides for you.
Very good. Thank you, John. And thank you very much for the 4 webinars. I hope everybody was able to get a lot of information. It's timely in that, we talk about hydronics in details as we're introducing this product. So we want to make sure that you have the right resources. If you don't have John's books, you might want to take a look at that as well. I've used modern hydronics quite a lot. So as far as resources that are available, you will find that Enertech is really known for supporting customers. We have a lot of application materials, but we also have personnel to help out customers. And this is a particularly important, thank you, John, particularly important product for that. Our technical services department has an enormous amount of experience. I haven't added up all the years, but it's quite a lot. These gentlemen are available to support your distributors that you buy through in areas where we don't have distributors. We may have some dealer direct customers, and those contractors then call in directly to technical services. The hours are from 7 a.m. Central Time, which is 8 a.m. Eastern Time, through 5 p.m. Central Time, or 6 p.m. Eastern Time. Next slide, please. We also have a design services department, and these 2 individuals are great at helping out customers with equipment sizing, the geoanalyst software, unit replacements on the geothermal side, solar design. We're trying to look at the whole system. So we may have a combination of air to water, geothermal, solar, looking at what makes the most sense as we move towards more electrification and energy conscious renewables. Next slide, please. One of the tools I think you're going to want to take a look at is our geoanalyst software. Initially, this was developed for the geothermal products that we sell, but it also has now the Advantage air to water system in here, as well as some comparisons to conventional equipment. So you may want to try an Advantage air to water heat pump and see how that compares to an air to air heat pump, or a natural gas boiler with an air conditioner, something like that. So this is really helpful for those comparisons, but it also gives you some idea of operating costs with the air to water, bin data, that kind of thing. It's at geoanalyst.net. So if you go to that URL, you'll have a couple of different options here, buy or try. And if you're an Enertech customer, this is a no charge software. So that's one of the advantages of being a customer of Enertech. You get this software for free. Next slide, please. When you get into the air to water sizing, you'll be able to pick a number of different options. Right now we have 2 models, an 030 and an 060. Those are really nominal heating sizes, 30,000 or 60,000. And then you can pair that with either a radiant floor system with fan coils or both, and that changes the water temperatures. So it's looking at average temperatures for those two different types of applications, or a combination of both. You can also pick your backup heating. As John mentioned, there are 2 different indoor modules. There's an electric module and there's a dual fuel module. So depending upon where you're located and whether this is a retrofit or new construction, you may want to choose either electric or or fossil fuel backup. There's some states that have pretty impressive electric rates for dual fuel, where your electric rate might be half of what it normally is if you're using dual fuel backup. So that's something you want to take a look at. Hot water, you can choose a lot of different options here. It makes a lot more sense to pick the TurboMax water heater over some of these other options, simply because the efficiencies of heating domestic hot water with the heat pump are just so high relative to some of these other technologies. So even if you do have, let's say, a dual fuel application, you're going to want that TurboMax water heater as your primary water heater, and then maybe use your combi boiler for backup, or a gas water heater in series or something like that. So gives you all these options to choose from, and then once you hit calculate, we'll get operating costs, but also bin data. If you'll go to the next slide, please, John. So John talked about bin data quite a bit, and this is an example of Syracuse, New York, showing the different hours per year at the various bins. This is really what makes a difference with heat pumps in particular. If we take a look at the bin hours on the far left-hand side, you can see there aren't a lot of hours at those really cold temperatures, but there are quite a lot of hours in the milder temperatures. And when we look at the efficiencies and capacities of this Advantage air-to-water heat pump, it really shines in that 20 to 50 degree range. It's not bad even all the way down to -13. It still has a COP of around 2. But where you're going to get most of your operation, the COPs are in the 3 range. And so this is really important to look at the operating costs, but also it gives you a pretty good feel for where backup heat comes in, how the unit's operating, that kind of thing. So we use bin data a lot, not just on air to water, but on geothermal, so we can get appropriate sizing. And that's all part of this GeoAnalyst software. Next slide, please. This is the report from GeoAnalyst. It gives you the operating costs I mentioned, but also it echoes your design input, heat loss, heat gain, design temperatures, kilowatt hour costs, those kind of things. And then gives you the balance point. In this particular simulation, the balance point is -3 Fahrenheit outside air temperature. So the unit can actually carry the load all the way down to -3. At that point, it either needs the electric immersion heater to come on, or we turn off the compressor and we bring on the boiler. Okay, next slide. And here we have another poll question. So in this question, we're asking, how many of you have access to software for analysis of air-to-water heat pumps today? All right, we still have people voting. Okay, I think most everybody has voted, Carly. All right, so most do not. You'll want to go to geoanalyst.net and check that out, or contact your territory manager, your Enertech representative, to get a copy of that software. It's an online software, so it doesn't really matter whether you're using a Mac, a PC, an iPad. It's a web-based software, so good information. Thanks, John. We can go to the next slide.
Okay.
All right, part of the support that Enertech offers is training videos. We have 10 videos online. You can go at your own pace. They're anywhere from about an hour, I believe, is the longest one, and the shortest ones are around 10 or 15 minutes. There are 10 total available, and then there's a little quiz after each video, just to kind of check to make sure that that you were able to pick up all the information from that particular video. You can pause it, you can back it up, rewatch it, whatever you like. One thing that we are requiring for the purchase of these Advantage air-to-water units is that contractors go through all 10 videos. So that is a requirement. Some of you have excellent hydronic experience. Others are new to the technology. So even the ones who are highly experienced, there are some differences with the Advantage. This is really the only product that has all the parts and pieces together. So that indoor unit is actually part of the whole system. It's a Modbus communication between the outdoor and the indoor unit, so you do need that indoor unit for it to function. but that also saves you an enormous amount of time in piping and adding all the components, sourcing the components, and so forth. So it is important to go through these videos so that you are familiar with the product. It's quite a bit different than what's on the market today. It has a vapor injection, which is relatively new technology. You'll want to learn about how the defrost works, all that kind of thing. So that's all part of these videos. John Pendleton is our senior trainer in technical support. He put these together. And as I mentioned earlier, our technical support department is available to help out with this product. Next slide, please. One of the really important parts of the installation and long-term reliability is making sure that we have good water quality. This is really, really crucial in our air to water products, but also our geothermal products. And we actually offer Fernox as our preferred antifreeze and inhibitor. So along with those chemicals, we offer this test kit. It's a pretty simple kit, really. The original test kit had a lot more tests in it, but as we narrowed it down to what really is causing the most problems with regard to heat exchanger issues, pump failures, those kind of things, really boils down to primarily pH and hardness. Ammonia is in here simply because we have found that unfortunately we're seeing ammonia in rural areas more often than we used to, and ammonia just loves to attack copper, which is prevalent inside these units. So that's never a good thing. So we've added ammonia. The standard Fernox kit does not have the ammonia test. Enertech adds the ammonia test as well as some instructions and a test kit form that you see here on the left. So you're able to record the water quality when you start up that unit, and then you can check that on a regular basis. You don't have to check it as much as you might on a boiler system because the temperatures that we're using are much, much lower. So you may have less time in between adding inhibitor than you might on a high temperature system. You probably want to check it annually at first, but it's quite possible that maybe it only needs checking every 2 or 3 years, depending upon what you start with. You may have to add some inhibitor over time. The Fernox product is very, very easy to use. You can't really overdose the inhibitor. It corrects for both high pH and low pH. If you add a little bit too much, it's not going to hurt anything. So it's very, very easy to maintain, but the key is making sure that you test that water. This is really cheap insurance. It's also potentially a great addition of revenue because you're the local expert. You can go test the system, whether it's an Advantage air to water or it's a boiler system. You have the tools to test the water and potentially correct some problems that might be a long-term issue. So this is something that actually is part of our warranty requirements for both the Advantage unit and our geothermal heat pumps. We do require antifreeze on this product if it's going to be making chilled water. And it also requires the Fernox F1 inhibitors or an approved equivalent. So that is part of the warranty. And as John mentioned earlier, with some of the boiler manufacturers, it's just good practice, and it does directly impact warranty. We don't want unhappy customers. We don't want component failures. This is a really inexpensive way to ensure that we have good quality installations. Next slide, please. All right, I will turn this back over to John and Tim for any last minute wrap up. Thank you very much for your time.
Well, thanks, Jeff. Yeah, this is our final slide. We want to pause here. And Carly, are there some questions that have come in that, we can direct these questions? I'll take a look at some of them, or Jeff or Tim, depending on what the question is.
Yes. So one question was, why do you suggest 1-inch copper as opposed to PEX supply in return to and from the manifolds when this is utilizing low temperatures? Is it necessary to utilize a bypass valve when utilizing the variable speed pressure regulated circulator?
No, copper is kind of a traditional hard piping material in hydronics, but certainly the temperatures and the pressures involved, they could use PEX. today, again, copper is being used, actually in the photograph over here on the far right, you can see copper tubing with some what are called press fittings. These are becoming a lot more popular. And again, the pressure and temperature rating on press fittings well exceeds anything that these heat pumps will be operating at. It really comes down to the installer's choice. Some people like copper. They like, very straight plumb, just, the workmanship, the appearance of the final product. They prefer PEX. I'm sorry, they prefer copper over PEX, but PEX certainly can be used. I will tell you that when you're making trade-offs between copper and PEX, 1-inch PEX does have a smaller inside diameter than 1-inch copper, and it does have an effect on pressure drop. And there are, again, there's software, there's tables. You should be evaluating that. Don't assume, for example, that if you designed a circuit around, I'll pick a large number, maybe 150 feet of 1-inch copper, and somebody says, can I use PEX there? Yes, you can. It is going to have a higher head loss compared to the copper. So as long as you're doing the calculations, the piping materials are, pretty much whatever you prefer. I will say PEX does have some advantage in chill water applications, but don't make the mistake of not insulating PEX tubing in a chill water application. The surface temperature will still get below the dew point and you'll still get condensation. Not as much as with copper, but you still do need to do the insulation on that.
Okay, the next question was, does this mini-series count towards NATE credits?
I honestly don't know the answer to that. I don't believe there was any specific certification by NATE of the content. Jeff or Tim, do you have any input on that?
No, I don't believe we do at this point. I don't know if it would be possible to submit the hours. I know some areas, if you've attended a certain number of hours, that may qualify, but we didn't specifically ask for any sort of NATE CEUs on these webinars.
Okay, the next question is, will this work with the warm board products, assuming it isn't a high mass product?
Sure, just so everybody knows, warm board is a pre-manufactured panel. It's a 4x8 foot plywood substrate that has grooves and a layer of aluminum that's bonded to the top. And it's designed to act as both a structural subfloor and a heat dispersion panel for tubing. And sure, this could work with that. As I say, when we were talking about the heating only application, we talked about the high thermal mass slab. During defrost, energy would come out of that slab. But remember that does have the electric indoor unit. It does have the 9 kW resistance heat. So with a warm floor type of system, you don't have as much thermal mass. There still is significant mass there, but if necessary, the electric element would operate in defrost mode. If it is a dual fuel unit, dual fuel version of the Advantage heat pump, you do need to have that TurboMax tank there as a thermal mass that possibly would be accessed during defrost.
Okay, the next question is, can we get access to the product data and installation specs for these units?
Certainly, yeah, those are on the website. If you go to enertechusa.com, you'll find at the top of the page there a graphic that shows the Advantage heat pump, and that will lead you to the product information. There's an installation, operating, and maintenance manual, as well as a submittal data manual. So you'll find both installation information and capacity and efficiency information.
Okay, and this kind of goes along with it. Can you get the schematics with the WB training? And those can also be found on the website.
Yes, those are on the website. In the installation manual are the both piping schematics as well as wiring schematics.
Okay, the next question is defrost time. What is the average duration time it takes to defrost? What is the average duration in defrost mode?
Well, the answer is it depends. There's quite a lot of variation depending upon the amount of moisture in the air, the temperature, how long it's been running. So it typically is going to defrost for 5 to 10 minutes, but it could be less than 5 minutes. The max, if I remember right, is about 12 minutes.
Okay, and the next question is availability or estimate costs for the AV 30 or 60.
Tim, I'll let you take that one.
Yeah, and Carly, what I would ask whoever is reaching out with that question, if they could come back into us, as Jeff had mentioned earlier in the webinar, we have a lot of our distributor customers that will be handling this product, as well as even in some markets, if we don't have a distributor, we would certainly look at that mechanical contractor as a customer with Enertech. So we do have pricing, and as far as availability, certainly by the end of this month, we anticipate being able to build these and have them absolutely ready to go. So I would say early March, we would have no problem getting these products out to people. But again, Jeff, thank you for touching on that video series. That is going to be a prerequisite. So if everybody could help knock out those 10 videos, and then that will already be checked off when they're ready to purchase.
Perfect. The next question is on larger homes that have a higher load, like a 5-ton, can we use multiple Advantage units staged together, or how would they be piped and wired in?
Yes, you certainly could. We have support to help with those types of applications. It sort of depends on how many zones there are, how many fan coils, what type of heating that we're looking at. Do we need domestic hot water in maybe different areas of the house? So definitely we can use multiple units. Probably the best way to get started on that is to define what you're trying to do with it as far as number of zones, type of system, and then we can dig into how that might work best.
Okay, the next question is, and this looks like the last question, do the variable speed pumps turn off when there is no demand call?
No. Well, it does depend. It depends on how they're wired. For example, if you're doing a hydronic system and you're using a multi-zone relay panel, and they're available from a lot of different companies today, and you're using zone valves, you could set the circulator up so that if all the zone valves are closed, it de-energizes. If you're using thermostatic valves on panel radiators, there's no electrical feedback from those valves. So in a case like that, what the pump will do is if it detects that all the thermostatic valves are closed, it goes into what I call a sleep mode. And sleep mode is it would still be spinning, but at a low speed, and it only draws anywhere from about 5 to 9 watts. And it's a very common application in European systems. The pump doesn't completely shut off, but it goes into this mode. And it goes into this mode so that when a thermostatic valve starts to open, it can detect that. It can feel a slight drop in pressure when one of those valves starts to open, and that's the wake-up call. So it comes back out of the sleep mode and goes into its normal, either proportional differential pressure control or constant differential pressure control. So the answer is yes, you could wire the pump so that if you have electric zone valves and everything is off, you could shut the pump off. But in a system where you're using non-electric valve-based zoning, there's no problem in letting that pump just go down into that sleep mode. It uses pennies a day of electricity, and it's, as I say, it's a very common application in the European market. Not as well known yet in the North American market, but I suspect that it will be.
Okay, we have one more question. Does the Advantage provide better energy efficiency in warm climates like South Florida compared to high efficiency variable speed compressors and DX cooling systems?
No. I guess the answer is no, and it depends. Anytime we're cooling with chilled water, it is going to be less efficient than a DX system, but we also get the advantage of domestic hot water. So if you look at it on an annual basis, I haven't done any calculations in Florida, but in Texas, with the exception of this week probably, if you look at domestic hot water and you look at heating and cooling, the cooling efficiencies are less with a hydronic product like this than they would be with a DX. But if you have enough hot water load, it's easily offset. So we have to really look at the total system rather than just specific efficiencies. So it's going to depend also on how much hot water load you have versus cooling load, that kind of thing. But in general, the DX efficiency is going to be a little bit better. It just doesn't have the capability to do domestic hot water.
Okay, we had one more question come in. Does this qualify for air source heat pump rebates in New York, and how?
Well, I live in New York. Right now, NYSERDA does have a program for low ambient or cold climate air source heat pumps. To my knowledge, this product or other air to water heat pump products are not currently on their qualified technology list. We are working on that. I do think there are folks within NYSERDA that see this as another sector of the air source market, and one that's particularly applicable in a traditional hydronics market. So right now, the answer in New York is no. Vermont does have a program, and the unit is fully qualified for the rebates up in Vermont.
Okay, and that looks like those are all the questions today. Is there anything last minute things you guys need to put in?
Carly, this is
I'll
Tim.
just thank
Go ahead, John.
Yeah, thank you to all the staff out at Enertech. It's been fun to put this together. It's been a lot of fun to present it. So Tim and Jeff, and Jim Cusack, as well as others, Carly, thank you very much for your help in putting this together.
Yeah, thank you, John. And I would just add that whoever was asking about the New York territory or NYSERDA area, I would encourage you to take that back to the utility and also ask that question. And we'll certainly carry that torch with you and for you. So thank you very much for that question. But overall, just to wrap up, thank you so much for taking time, expanding your knowledge with this emerging technology, air to water industry. Everybody that's taken the time in this 4-part mini-series, certainly you've expanded your knowledge, and we thank you for your time investment. We look forward to assisting you in any future design, whether it's residential, whether it's retrofit, as John has spent a lot of time spending this opportunity to be able to highlight how we can do it, even in retrofit applications. So awesome. And again, Carly and Jeff and John, thank you so much for your efforts in bringing this series to our industry. And have a great day, everybody. Thank you for tuning in.